Let me acknowledge my co-author, Dr. Lan from the Academy of Sciences in Beijing, China, who is here today, and he'll be able to answer your questions, which I won't be able to, about the animation which we hope to show you later in the talk. Under David Vaughan's chairmanship, our IAEG Commission on Landslides asserted principles in its first technical publication 30 years ago. The first principle, the present and the past are keys to the future, meant that natural slope failures in the future will most likely be in geological, geomorphic and hydrological situations that have led to past and present failures. We have the possibility to estimate the style, frequency of occurrence, extent and consequences of failures that may occur in the future. This optimistic first principle is an echo of earlier remarks about principles made in Charles Lyell's great 19th century manifesto, Principles of Geology. Lyell wrote that some geologists, and this was his code for I, infer that there has never been any interruption to the same uniform order of physical events. The same assemblage of causes they conceive may have been sufficient to produce, by their various combinations, the endless diversity of effects of which the shell of the earth has preserved the memorials, and consistently with these principles, the recurrence of analogous changes is to be expected in time to come. These views, of course, caused him problems with a 30-year struggle with Darwin's ideas, and they had more serious defects because they suffered from the logical problem, the problem of induction, described 50 years earlier by Charles Darwin's countryman, David Hume, of whom we have a picture here. And Hume pointed out that though none but a fool or a madman would ever pretend to dispute the authority of experience or to reject that great guide to human life, it'd surely be allowed a philosopher to have so much curiosity, at least, as to examine the principle of human nature, which gives this mighty authority to experience and makes us draw advantage from that similarity which nature has placed among different objects. From causes which appear similar, we expect similar effects. This is the sum of all our experimental conclusions. Hume's challenge to philosophers was taken up 200 years later by the great Austrian philosopher of science, Karl Popper. It's not necessary to be bold to work in this field. Really, it's an occupational hazard. Without waiting passively for repetitions to impress or impose regularities upon us, we actively try to impose regularities upon the world. We try to discover similarities in it and to interpret it in terms of laws invented by us. Without waiting for premises, we jump to conclusions. These may have to be discarded later should observations show they are wrong. So, we have a working hypothesis which I think incorporates the principles of the first of the publications of the Commission on Landslides. We hypothesize that similar landslides in similar materials are caused by similar processes under similar conditions. Fortunately, the working classification of landslides has defined similar types of landslides and similar materials during the 1990s when the IAEG Commission joined the UNESCO Working Party on World Landslide Inventory to define a whole glossary of terms. Since then, we've introduced some new terms: preparatory, marginal, repaired, and split earth into three. To cope with frozen ground, Régin Couture, the current VP North America, introduced two terms for water contents: frozen and thawed, from the permafrost literature. So some of the new terms we've introduced, particularly then frozen and thawed, and we've divided earth into three: sand, silt, and clay. This through the agency of the new ISO standard. Permafrost is important. Frozen and thawed ground extend over a quarter of the Earth's surface. 55% of the northern hemisphere is seasonally frozen. 24% of North America is underlain by permafrost. Coming from Canada, we think this is important. Obviously, the Chinese and Russians think this is important too. Let me show you some typical movements in frozen ground, because this is sometimes difficult to get to. Here, this is a retrogressive thaw flow, which in our classification is a thawed earth slide. The earth thaws and then slides, and because the melted ice water cannot escape, it turns into a wet earth flow. For more cohesive material, this thawed earth slide here turns into a very wet earth flow, which flows on angles of perhaps 2 to 3 degrees. Again, there's no downward drainage of water in the permafrost because the ground below the active layer is frozen and the water can't escape. But it is useful for us to define different types of soils, because they show different responses then to slope movements. First, of course, the ISO standard allows us to define rock and soil, and one of the peculiar characteristics of landslide classification systems is that we haven't gone ahead and subdivided rock, and this is something that needs our attention. For soil, we don't distinguish in the classification between anthropogenic soils, made ground, and natural soils. And of course, this distinction between sand, silt, and clay can be easily made in the field, and is a useful thing to do. Here, for instance, from eastern Canada is a clay spread, and you can see that the displaced material has held together in substantial blocks. In contrast, the same stratigraphic unit where it's a silt breaks up and flows. So this is a silt flow. The different types of movement then, and perhaps the animation will appear. No? Oh. Our fall? Nope. A topple. A slide. And you'll notice in these cartoons, because this is what they are, these are from Varnes's classification. These cartoons then, all the displaced material starts moving at the same time. This, I'm told, I assume simplifies the programming, but we can make other choices, and perhaps we should indeed, and these will increase the variety then of movements that we'll see. And here we've got a flow which is caused by a torrential downpour, and off it goes. And similarly with this spread. So these are some assumed patterns of movement which, as I should note, are not the only alternatives, and we need to explore then what else can possibly happen. It doesn't all have to start moving simultaneously. There's also a series of descriptors in the classification for the various stages in landslide movement and the activity of those landslides. In the classic picture here, originally from Terzaghi's drawing, the landslide moves from the slope moves from a stable state to a marginally unstable state through the action of preparatory factors, and then a trigger sets the landslide in movement. Unfortunately, Terzaghi inserted the factor of safety on this axis, and I'd caution you that this applies to a particular mode of movement, not to the slope generally. It's impossible to detach the factor of safety of a slope from your hypothesis about how it may move, and this is something which has not really been explored, perhaps as much as it might be. The committee, the working party, explored the causes of landslides and separated them into ground causes, morphological causes, physical causes, and artificial causes. All these can be preparatory, but of course only the geomorphological causes, the physical causes, and the artificial causes can act as triggers. And just as a reminder, we've put up here a list of artificial causes. We tend to call deforestation, ground clearing in Canada, and Scott Burns has admirably demonstrated the hazards that this entails here. The activity of a landslide can then range through a large number of stages, and we've added to this preparatory and marginal. And here's the states of activity that we originally set out with. Topples there, a diagram you're probably familiar with. We've added down here at stage 7 repaired or to stabilize, because frequently the engineers tell us they're not sure that they've stabilized it, they're just sure that they've repaired it. So after a century or so, we can assume the slope has been stabilized. We can illustrate these stages with John Hutchinson's famous diagram on the London clay. And here he shows the transition from a marginal stage at the top here, stage 1.5 as we've called it, where the rupture surface is just forming, through an active state, stage 2, where actual movement takes place, to a reactivated stage where every tide at the base of the slope causes movement, to a suspended state where every high tide might cause movement, to a dormant state where it's only activated by very large storms getting up the beach and getting to the slope. And finally, when all traces of the first cycle of the movement have been removed, we're back at the preparatory stage where we're about to start all over again, and people will build houses on the top there, not knowing, of course, that it's a landslide area. There are different distributions of activity and different styles of activity, all these things that the Working Party documented in the 90s. We introduced a revised velocity scale, which went up in nice even increments of 100, and correlated this through the good work of Aldrich Hunger to the destructive significance of these landslides in the various velocity classes. So, to get back to the original topic, the hypothesis that similar landslides in similar materials are caused by similar processes under similar conditions. First, we must, at the site we're examining, identify the materials and the disturbing processes which are acting on the site. Then we must examine other sites in the material where similar processes have caused movement, and here as Scott has noted, a landslide inventory is most helpful. So we can then fully identify the type of movement that we can expect at the site on this particular natural slope, and then we can develop hypotheses about how likely that is to happen. So this work in the 90s was conducted by an IUGS working party on world landslide inventory. Some of the guilty parties are noted there. My own work has been supported by the Canadian Natural Science and Engineering Research Council, and clearly we now have an urgent need for a revival of the Landslide Commission, perhaps as a commission on landslide nomenclature, which is not being addressed by any of the international bodies at the present time. And Helen Reeves on the IAEG Council has taken some initiatives on this, and would be glad to hear from those of you representing national groups who would like to participate in this. The first and most urgent issue is a second edition of the International Landslide Glossary, which contains accepted definitions of terms in the UNESCO languages and in the language, of course, of ISRM German. So if you're interested in pursuing these topics, Helen would like to hear from you. Thank you very much for your attention.